Hello, judges. My name is Waleed Solomon. This is Mubin Hyder, Troy Toledo, and Joe Samuel. I'm an electrical engineer, computer engineer, electrical and computer. We have the facial recognition security system. Just to throw it out there, we won first place for Senior Design 1, even though we were the most doubted and most controversial group for Senior Design 1. And I don't know why everyone didn't believe in us. I mean, it was just a few lines of code and a camera, really. So it wasn't really that complicated, was it, boys? That's all right, okay. So basically what it is, it's a facial recognition security system made for residential households. So it replaces your door key. So you walk up to the camera, it recognizes your face based on stored images in the database. And to give my group a chance to talk, Mubin's going to talk about the code.
So the code is fairly simple. We're taking the camera input and we're processing it into two dlib libraries. This is the face cascade library and the eye cascade library. Basically, it maps the facial features into 128 and 68 points. From there, it's really simple. We do a for loop and we traverse through the array that the points are stored in. And basically from there, we're just matching the points to our embeddings that's in the deep network. And that's really how it functions.
So for our judges, it's safe to say that you can put your checkbooks away. Our product is still in the prototype stage. It's not quite ready for the shelf. So what we have is a machine capable of deep learning algorithm. It's able to establish its own neural network. And with this, we have a database of the unknowns is 20 different countries. We have a male and female from each country, which is a total of 40 different photos. Each of our group members inputted a total of 20 each. And so our machine is capable of running and serializing 120 photos in roughly 30 to 40 seconds. And with this being pretty fast, the reason why we say it's not quite ready to hit the shelves is even though me and our partners are still in the database, it's probably equivalent to a superhuman 4-year-old. It doesn't quite understand that the end user can only be one person. And so it starts to, depending on the angle accuracy, it starts to pretty much get me and Mubin confused. But overall, if you get a random person that's not in the database, that is the same ethnicity or whatnot, it would determine accurately the unknown versus our team members in this case. And during the process, we were measuring up to temperatures between 89 to 139 Fahrenheit degrees. And with static image, we actually had a higher % confidence. So with the still image, it's able to accurately represent who the end user is a little bit better than real-time facial recognition does. But with the blink detection, because we chose the Jetson Nano, it's actually the bottom of the totem pole when compared to the other NVIDIA products. And so with the blink detection, we have to run a separate script. And what this does is in order to prevent someone holding up a picture to trying to get into your house, it recognizes the facial features of your eyes. So whenever you blink, it gives you a linear value of 0. And so that's how it represents that the person blinks. And so we have a tracker that also counts the amount of blinks into who the end user is. So it's able to keep a track of how many times the person has blinked in total. So like I said, this is 2 separate scripts because the Jetson Nano, we were aiming for cost effective. And so roughly at retail value, it's $99, whereas the next machine is about $500. So depending on what you want to pay for. And but overall, we have a very high accurate machine, and we're comfortable to show y'all as y'all come into our group after this. And I'll pass it on to Joe to conclude everything.
So this might not be the last time you see a facial recognition system because Dr. Bhatia intends to continue with this project in the next semester. So what we did, we achieved an accuracy, facial recognition accuracy rate of greater than 70%. This is because of the amount of data we trained our system with. But our system is designed to increase the recognition accuracy rate as long as you keep using the system. So what we did is simply more data, more accuracy. So, and that's simply it. Thank you very much for listening, and see you at 8H3 for the project demo.
Yeah, I had a question on how much power do you use and how long will it last where you have to change the battery?
Because it's a prototype, it uses a 5-amp plug. So as long as you leave it plugged in, it operates. For our testing, we had at least a week straight, and it showed no lagging issues, no deficiencies. But like I said, it's still a prototype, so we weren't able to include a battery. So at this point, it would need to be plugged in.
Does it learn your face over time? So like if it's looking at the same person all the time, it gets more and more accurate toward that person?
Yes.
Yes, it does. For this, because it's a prototype, you have to input the photos manually, whereas video recording is real-time facial recognition. So in order for it to learn your face manually, you have to input more photos, but we weren't quite able to establish the file to memorize in real time. Does that make sense?
Yeah, okay.
Sorry, so it sounds like you're using a 2D image to actually let this machine learn?
Exactly.
But you're then also using a camera to capture all these different points in a 3D plane.
Exactly.
How's that effective though?
So the way it works is basically the database, it contains all these pictures, and it's a quick process to basically serialize all the embeddings, and then the camera is just real time. It basically, it's like an input. You walk up to the camera, and then it uses the real-time image to match with the image in the database, and then it authorizes the unlock.
One last.
How do you hook
Oh.
this, how do you hook this camera into the lock? I mean, if, it can't be on the door because you have to have wires, right? So you have to have the camera somewhere else, but you still have to have the lock on the door. So do you Bluetooth to that lock, or how do you actuate the lock?
No, it's wired into the microprocessor. It's wired into the board. You can see it downstairs. It's like the box. It sits right on top.
No, I'm
so-
just asking, I'm asking if you have the camera on the wall beside the door, how do you get to the lock?
It would have to be an electronic lock system with via Bluetooth,
Bluetooth,
for
okay.
that case.
All right.
So what's stopping you to train it more? Is it the time? Like you can
Yeah.
train it?
Yeah.
The biggest learning curve was learning how to operate Ubuntu, which is the operating system of the Jetson Nano, and obviously Python and OpenCV, and learning how to create environments to separate Python 2.7 versus Python 3, OpenCV 4 versus OpenCV 3. So these are just kind of issues that we ran into that we're having to kind of dance around to figure out the overall issue at the end.
So,
All right. One last. Sorry.
no, that's fine.
While you were training your software, did you have anything in there to prevent bias from being introduced?
As far as viruses,
Bias.
Bias.
You know, cultural bias.
that was because we chose 20 different countries. That is one of the factors that we do. That's another reason why it's still in the prototype stages, where that doesn't affect the outcome of the conclusion of the machine. The ethnicity and the skin tone is really the biggest factors that we ran into.
So we created our own database of a geographical ethnicities, and then we are also using Google's. They have a trained data set of multiple people from all over the world, and that's basically how we're kind of differentiate between bias.
That's the reason why we chose 20 different countries, each having a male and female.
All right. One very last one.
Thank you. How many data points does your system look at each time you analyze the face?
It's 128 for the face and then 68 for the eyes.
All right. Let's thank the team.